Okay, now we will describe to you the Ecg Signal Expression at the digital lab of the Electrical Engineering Department at FAST campus at Peshawar. Okay, now let's describe. First of all, you will have an instrumentation amplifier because of high gain and low impedance requirements. And here we have an RG, which is used for gain control. And here we have a very famous instrumentation amplifier INA118, and this is the output. And then we will connect one arm signal, which is left arm, to the positive side, and the right arm to the negative input of the INA. And now we connect the shield to the ground of the first operational amplifier. We have, this is OP07, and here the 3 of which is connected, which is the positive side, to the virtual ground, and 2, which is the negative, is connected in a feedback manner to the output. And now this one, through a resistance which is 10K, is connected to another op-amp, which is again the second part of the OP07 we have, and this is to the inverting side, to the -2, and 3 is grounded, and the output of this is connected through a 390K back to the input in a feedback manner, and the output of this is connected through a 390K to our right leg. This whole arrangement is called right leg driver. So now we have left arm connected, right arm connected to the instrumentation amplifier, and the right leg is connected through these two arrangement of the op-amps to the virtual ground, and this is our circuit for extraction of the ECG. Now schematic is complete. Let's move back to the bench. Okay. Now the bench part is done by Mr. Rahmatullah Kundi, and this was, before that, this was Asmatullah, which is a professor at the FAST, and now we will move to Rahmatullah Kundi, and he will be used as a patient as well as for extracting his ECG. Okay, please have a seat. And now, okay, first of all, we will show you what the electrodes look like. These are the electrodes with us. And now we are going to connect them. We need left arm, right arm, and now we are connecting this green to the left arm. This is the left arm here, and red to the right arm. Okay. We need to stick it very firmly. Okay. And now we need right leg. We will take the socks off a little bit. And now we are going to connect it to the part which should not contain any bone. And now we have connected all the 3 components. And now here is the power supply, and now I'm turning on the power supply. You can see we have 2 9-volt batteries from where we are getting -9 volt and +9 volt. And here is our circuit that we shown you on the blackboard, and this is the practical. This is INA118, and these are 2 OPs, and this is basically another amplifier we added just to boost up the signal 741, a very common signal. Okay, and now we move towards, and you can see very clearly here the signal on the oscilloscope. It has the heartbeat there, and now we will need basically this oscilloscope is for audio signal range, so 20 to 2 kilohertz. We want to have an oscilloscope which we basically have on the laptop, and here we turn it on, and here is our laptop version of the oscilloscope, which is good for our signal because our signal is in millivolts. And here we use, and now let me go back to our oscilloscope, and as you can see, we have basically a voltage peak to peak which is 700 millivolt, and here we can see very clearly our signal, which we were not able to see it on the conventional oscilloscope. And this oscilloscope is basically can display a very low frequency signals, because our frequency for the ECG signal is only 0.5 Hertz. So we need to go for this storage oscilloscope facility that is available on a download version of the oscilloscope software on our laptop. Okay, and for this we make a cable, and this is our oscilloscope cable, which is connected to the mic input, and it went down on the table and it has been connected to the output. And here is the ground cable, and this red one is one channel and white one is the second channel, which we are not using currently. And here is our signal. We can clearly see that there is an activity which is present, and we can have all type of requirements satisfied right now. And now we will go and record this particular signal so that we can digitize it, and after digitization we would like to do some digital signal processing on top of it, because here we are getting a contaminated signal in the form of 50 Hertz contaminated with our ECG signal. Now here is basically what you are seeing is a window which contains all the recording options. Here is the data samples, 200 samples. Here is the data samples, 200 samples per second with a resolution of 16 bits. And now here we have a recording buttons, stop and stop button, on, pause, stop, and now we can save the whole of our waveform in a file with the wave format. Once we save it, we brought it to our desktop with the name of Asmat right now, and after going to the MATLAB, we import this file here as a signal Y, and then we have performed the notch filtering in the digitized domain, discrete domain. And now we can show you the plots, and the plots are, as you can see very clearly, there are two plots on top of each other. The upper plot is 50 Hertz along with the required ECG signal, and the lower one where we have depressed the 50 Hertz signal 80 dB down, so that we can clearly see that our ECG signal. So our ECG signal was weaker, 80 dB weaker than the power frequency signal. Although we have used a common mode rejection, still we need to do this 80 dB depression for our 50 Hertz power line signal. Now we can very clearly see that the lower plot does show the proper complex for the ECG, PQRST. And with that, we came down to the end of this presentation at the Digital Lab of the Electrical Engineering Department at FAST NU National University campus at Peshawar. Thank you very much.